Hello everyone. Once again, welcome you all in Mathematics by Mathmedia. So let's start our today's lesson. The topic is prime and composite numbers. And the outcomes for the lesson are analyze numbers to determine if they are prime or composite, evaluate a list of numbers and justify their classification as prime or composite, create your own examples of prime and composite numbers and explain their reasoning. So let's start. First of all, we are going to learn what are prime numbers. So we can say these are the numbers that have only two factors. It means 1 and the number itself are known as prime numbers. Or we can say the numbers that are completely divisible by 1 and the number itself only with zero remainder are prime numbers. Let's take some examples. So, 2. How many factors does it have? 2 is having only two factors, 1 and the same number itself, 2. So, it is having only and only two factors. So, it is a prime number. It means 2 is divisible completely with zero remainder by 1 and the same number 2 itself only. So, it's a prime number. Let's take one more example. Suppose I'm writing here 17. So how many factors does it have? 17 is also having only two factors, 1 and the same number itself, 17. It means 17 is completely divisible with zero remainder by 1 and the same number 17 itself. Once again, two factors only. So it's a prime number. So we can say a number that has only two factors, 1 and the same number itself is a prime number. Those numbers are called prime numbers. Let's move furthermore. Now the next is about composite numbers. These are the numbers that have more than two factors. And what will be those factors? More than two factors? 1, the same number itself, and other factor or factors. But the main point is more than two factors. Or we can say the numbers that are divisible by 1, the number itself, and by any other number or number or numbers are composite numbers. Let's have some examples. Suppose I'm writing here 8. Let's check how many factors does it have. 1, 2, 4, and 8. So we can see here 8 is having total 4 factors. So it's a composite number because more than two factors. So any number that has more than two factors is a composite number. It means 8 is completely divisible with zero remainder by 1, 2, 4, and 8. So it's a composite number. Let's have one more example. I'm writing here 12. So the factors are 1, 2, 3, 4, 6, and the same number itself, 12. So it means it has 6 factors. So it's a composite number. The reason, because it has more than two factors. So it's a composite number 12. So we can say any number that has more than two factors, one, the number itself, another factor or factors is a composite number. So let's move to the next. Now analyze numbers to determine if they are prime or composite. So how to do this? We have already learned what are prime numbers and what are composite numbers. Now we can easily analyze the numbers whether prime or composite. So the number is given here 16. So we know the factors of 16 are 1 and 16 because 1 times 16 is 16. So 1 times 16 is 16. And other factors are 2 times 8 is 16. So we can say 2 into 8 is 16. And other factors are 4 times 4 is also 16. So the factors of 16 are, we can say 1, 2, 4, 8 and 16 because 4 times 4, 4 multiplied with 4 is also 16. So 1, 2, 4, 8 and 16. These are the factors of 16. So how many factors does it have? 1, 2, 3, 4 and 5. It has total 5 factors. It means we can say it is having more than 2 factors, that is satisfying the definition of composite number. So 16 is a composite number. The reason is that it has more than 2 factors. Let's move to the next. Now we have one more example, 29. So how many factors does it have? So 29 is 1 into 29 is 29. And any other factor of 29? Let's think furthermore. No, I don't think so. So it means 29 is having only two factors, one and the same number itself, 29. It has only two factors, one and the number itself. So it's not a composite number. Actually, it's a prime number. 29 is a prime number because it is having only and only two factors, one and the same number itself. So in this way, by finding the factors, we can easily analyze what are prime numbers and what are composite numbers. So let's move furthermore. What about 1? 1 is neither prime nor composite. Why? Because we have learned what are prime numbers. Prime numbers have two factors. If we are talking about prime numbers, only two factors. And if we are talking about composite numbers have more than two factors. But what about 1? 1 is having only one factor. 1 is only divisible by 1 with zero remainder. 1 is having only and only one one factor. So it's neither prime nor composite because for being prime number it should have two factors, and for being to be composite it should have more than two factors. So we can say one is neither prime nor composite. So remember this is also one of the most important thing. Let's move to the next. Now we have a list of numbers and we will evaluate and justify their classification as prime or composite. So easily we can do that. If we talk about one is have one is having only one factor. So one is neither prime nor composite, neither prime nor composite, as we have just discussed in the previous slide. And what about 2? If we talk about 2 is having factors 1 and the number 2 itself. So we can say 2 is a prime number. If we talk about 3, 3 is also having only two factors, one and the same number itself, 3. So it is also a prime number. 3 is also a prime number. What about 4? How many factors does it have? 1, 2, and 4. 4 is having three factors, 1, 2, and 4. But it has more than two factors, so it is not a prime number. 4 is a composite numbers because more than two factors. Now, what about 5? 5 is having two factors, 1 and the same number itself, 5. So we can say 5 is a prime number. What about 6? Let's move to the next. 1. Factors of 6 are 1, 2, 3, and same number itself, 6. So how many factors it has? We can easily see here it has 4 factors. So more than 2 factors means it's a more than 2 factors. It means we can say it's a composite number. So 6 is a composite number. Now what about 7? 1, factors are 1 and the same number itself, so it's a prime number. 8, the factors of 8 are 1, 2, 4, and 8. So it is also having 4 factors in all. It means more than 2 factors, so we can say 8 is also a composite number. What about 9? How many factors? 1, 3, and 9. Total 3 factors in all. So more than 2 factors, it means it's also a composite number. Now let's check about 10. 1, 2, 5, and 10. So these are factors of 10. Total 4 factors, but more than 2 factors. So we can say it's a composite number also. So these are the natural numbers starting with 1, and we have already discussed 1 is neither prime nor composite. But in this list, we can easily analyze the smallest composite number, not the composite. First, we will talk about the prime number. The smallest prime number that is also even is 2. The 2 is the smallest prime number. The smallest prime number is 2. The smallest prime number is 2. That is also that is also even, because all other even numbers are composite numbers. All other even numbers greater than 2 are composite numbers. The only even prime number is 2, and the smallest prime number is also 2. And what about the composite number? The smallest composite number, we can see here, 1 is neither prime nor composite, 2 is prime, 3 is prime. So the first and the smallest composite number is 4. 4 is the smallest composite number. And here we talk about 2. The smallest prime number is 2. that is also even. So, in today's lesson, we have learned about prime and composite numbers and how to check the given numbers are prime and composite. So, now one task for you, you can create your own examples of prime and composite numbers and explain their reasoning why prime, why composite. So, you can think your own numbers, any of your five favorite numbers, or some numbers you can take and you can decide whether prime or composite. So this is your practice task. In today's lesson, we have learned about prime and composite numbers. See you in next lesson. Like, comment, share, and subscribe my channel, Mathematics by Mathmedia. Bye everyone.